So composition of two functions is defined as f of g of x is f of g of x, right? So let's see. If you have f of u as sine u, g of x is 1 plus x squared, what is composition of these two functions? So we have f of x is a composition of these two functions. So f of g of x. Now this is going to be f of, now g of x is 1 plus x squared. And for this function, so f of u is sine u. So f of 1 plus x squared is going to be sine of 1 plus x squared. And our goal is to be able to take derivative of this function, which is sine of 1 plus x squared. So how do we go about it? Now, if we could relate this derivative of sine of 1 plus x squared with sine and with 1 plus x squared, we would be good to go because we know derivative of both of them. So derivative of sine u with respect to u is cosine u, and derivative of gx with respect to x is 2x. So is there a way to relate to them? Is there a way to relate f and g with the composition? And the answer is chain rule. So what does chain rule tells us? So let f and g be differentiable function and consider f equals to f composed with g. This is a composition function. It's defined by f of x as f of g of x. Then the chain rule tells us that this composition of function is differentiable. And the derivative is given by f prime x is f prime g of x multiplied by g prime of x. So what does it mean? It means you basically, so you have f of x equals to f of g of x. This is your outer function. And this is your inner function. So then the derivative chain rule tells us that this function is differentiable if f and g are, and f prime x is derivative of outer function evaluated at inner function multiplied by derivative of inner function. So this is derivative of outer function evaluated at inner function multiplied by derivative of inner function. Okay. Now this same thing can be written in Leibniz notation. So if you want to use the same thing in d by dx notation, so let y be f of u and u be g of x. Then you're looking at dy by dx. That is same as dy by du times du by dx. It seems like as if that these guys are getting canceled, right? But that's not correct because these are not fractions to cancel, okay? So, but to remember, maybe this idea is helpful, but they are not fractions, right? So this is dy by du times du by dx. So this is what the chain rule is. So now let's do this problem. So f of u is sine u, g of x equals to 1 plus x squared. Let f be f of g. Find derivative of f. So in this case, we have f prime x is f prime g of x times g prime of x. This is the chain rule, right? Now we need to compute f prime. So what is f prime of u? So f prime of u is same as taking derivative of, so I can either write it as also as f of x equals to sine x. So what is f prime of x? F prime of x is going to be, f prime of x is going to be, derivative of sine x is cosine x, and g prime x is going to be derivative of 1 plus x squared, which is 2x. So then this is going to be sine x, but instead of x, you have what? G of x. So sorry, my bad. F prime is cosine x. So it's going to be cosine of g of x. So cosine of g of x is going to be cosine of 1 plus x squared times g prime of x, that is 2x. Yeah. So this is the chain rule. Now note that the beauty is you are able to relate. Note that f of x is going to be sine of 1 plus x squared. So you are able to relate the derivative of sine of 1 plus x squared with derivative of sine and derivative of 1 plus x squared. So using this, you can tackle more quote unquote difficult problems of derivatives. Okay, so let's move on to the next part. So we have y prime equals to dy by dx. If y, so find y prime if you have y equals to 2 minus 5x cubed. Now to do this problem, we can basically write it in the, this is going to be f of u, where f of u is u cube, and your u is what? 2 minus 5x. So we get what? Dy by dx, or you can write this as y equals to u cube as well. So dy by dx is dy by du times du by dx. So what is dy by du? So derivative of this with respect to u is going to be 3u squared. Derivative of u with respect to x is going to be minus 5. Now you put everything back in terms of x, so you get 3 times u is 2 minus 5x the whole square times minus 5. Yeah. Now there's another way to look at this. So you can do it directly, dy by dx directly. You can think about it as dy by dx is, now what is derivative of x cube? Derivative of x cube is 3x squared, right? So think about this momentarily as an x. So you get what? 3 times 2 minus, so I'm treating this momentarily as x, so x squared, so I get 2 minus 5x. We have to, although multiply x, the extra part is multiplication by derivative of inside function, which is this, and then what do we get? We get 3 times 2 minus 5x squared times minus 5. Okay, so you can deal with this problem directly that way. Okay. For that, you need to, you can prove this generalized power rule. Oh, my bad. So you, oh, the meeting, okay. So we have y equals to 2 minus 5x cubed. In that case, what we did was we basically treated y equals to f of u, where u is y equals to u cube, and u is 2 minus 5x. So therefore, dy by dx becomes dy by du times du by dx. And then dy by du is 3u squared times minus 5. Dy by du is 3u squared, du by dx is minus 5. Then you plug in back what your u is. Your u is 2 minus 5x squared. And du by dx is derivative of this with respect to what? With respect to x, which is minus 5. Similarly, in this case, you basically use product rule first. So you have u times derivative of v plus v times derivative of u. Now this guy will come as it is. Now what is derivative of 1 plus ex the whole square? So you treat it momentarily like an x. So you get 2 times 1 plus e to the x multiplied by derivative of inside, which is 1 plus e to the x, times 1 plus e to the x square. Derivative of this guy is going to be, again, you treat this shaded thing as x. So that is going to be 5 times x plus sine x to the power 4 multiplied by derivative of inside again. So we have x plus sine x to the power 5 times 2 times 1 plus e to the x. Derivative of this guy is e to the x. And then this guy as it is, 5x to the power sine x to the power 4. Derivative of x is 1 and derivative of sine x is cos x. So this is how it goes. Now let's do the next problem. So we have y equals to u to the power 5 and u is 4x minus 1 square over x. So we need to find out dy by dx, and the problem is asking to write the derivative in terms of x. So let's do this. So dy by dx is dy by du times du by dx. Now what is dy by du? So derivative of u to the 5 with respect to u is going to be 5 u to the power 4. Now du by dx. So let's compute that on side here. So what is du by dx? So du by dx, we'll have to use quotient rule. So x square times, so denominator as it is, multiplied by d by dx of numerator minus numerator as it is times derivative of denominator. So what do you get out of this? So we get x. Now derivative of this, so derivative of x square is, derivative of x square is 2x, right? So derivative of this is going to be 2 times 4x minus 1 multiplied by derivative of inside. So now I'm going to do it on fly. So this is going to be minus 4, sorry, times 4. Minus 4x minus 1 square times derivative of x is 1. The whole thing divided by x squared. So we're going to plug this back here. So we get x times 2 times 4x minus 1 times 4 minus 4x minus 1 square over x squared. Now we can put back what our u is. So we get 5 times 4x minus 1 square divided by x to the power 4 multiplied by 8x times 4x minus 1 minus 4x minus 1 square divided by x squared. You could have simplified this further if you wanted. You get 4 minus x by x square, the whole square. You can take 4x minus 1 common. What is left in the bracket? 8x minus 4x plus 1 divided by x squared, right? Which is going to be 5 4x minus 1 square by x to the power 4, 4x minus 1 times 4x plus 1 divided by x squared. Okay. So this is a simplification of this. Now let's do the following problem. So f of x equals to square root of 2 plus 5x squared, right? So now in this case, we write, this can be seen as 2 plus 5x squared to the power half, right? So f prime x is going to be, now what is derivative of x to the power half? Is half to the power half minus 1, which is minus half. So 2 plus 5x squared multiplied by dx of 2 plus 5x squared. So we get what? This is going to be half 2 plus 5x squared to the power minus half multiplied by derivative of 2 plus 5x squared, which is going to be what? Minus 10x. Yeah. So this is your derivative. Let's move on to the next one. Again, in this case, f prime x. So now the first thing you should, so first part you should, yeah, that's fine. That's right. So this is going to be, yeah, that's correct. Sorry, my bad. This is going to be 10x, not minus 10x. So now in this case, first you basically think about the outermost function, so which is x cubed. So this is going to be 3 times tan x square, the whole square, times d by dx of inside function, which is derivative of tan x square. Yeah. Now this is going to be 3 tan x square, the whole square. Now derivative of tan is secant square. So secant square x squared times d by dx of x squared. Yeah. So you see, it's like peeling layer of onion, one layer at a time. So you're taking derivative of one outer function at a time and then keep multiplying by the derivative of inner function. So we get this is equal to 3 tan of x square, the whole square, times secant square x square times derivative of x square is 2x. So this is your answer. Similarly, let f of x be e to the power cos x. So here the outermost function is e. So derivative of e to the x is e to the x. So f prime x is going to be e to the power cos x times derivative of cos x. That is going to be e to the power cos x times derivative of cos x is minus of sin x. So this is your answer. Yes, we could have also done it by taking f of x equals to, or y equals to, whatever you call it, y equals to cos u e to the power u, where u is cos x. So therefore dy by dx is dy by du times du by dx. So this would have become dy by du is what? Derivative of e to the u with respect to u is e to the power u. Derivative of u with respect to x is minus sin x. Now put back what your u is. So you get e to the power cos x times minus sin. Okay. So either way is fine. Yes, that's fine. So we could have taken all of them as u, but now I'm doing it on fly, right? One. Okay. So it's up to you. Let's move to the next part now. Derivative of a to the x is a to the x ln a. Now, how do we prove this? This is not the usual power rule. So note that this is not x to the power x times a to the power x minus 1. Yeah, this is not true. Yeah, because power rule only applies to x to the power n. So a variable or variable to the power a constant, not constant to the power variable. So how do we go about it? Now, notice the following. We can convert this problem into, so a is same as e to the power ln a. And of course, we are assuming here a is greater than 0 and a is not 1. So now, if you take power x on both sides, you get a to the power x is e to the power ln a. the whole power x, which becomes e to the power x ln a. So you have rewritten a to the x as e to the power x ln a. Now see, this is a very common theme in mathematics, right? You reduce it to a problem which you already know. You know how to take derivative of e to the power something. Yeah. So derivative of a to the x is going to be derivative of e to the power x ln a. Now derivative of e to the x is e to the x. So derivative of e to the x ln a is going to be e to the power x ln a multiplied by d by dx of x ln a. Now what do we get? So we get this becomes e to the power x ln a, and derivative of x ln a with respect to x, the ln a comes out, it's a constant, times derivative of x, which is 1. Now we only temporarily needed this. We'll convert it back to a to the x. So a to the x ln a. So derivative of a to the x is a to the power x ln a. Okay. Okay. Let's do the following problem now. So let's read the problem. A pebble is dropped into a lake, creating a circular ripple. Suppose the radius of the circle is increasing at the rate of 2 inches per second. At what rate is the area increasing when the radius is 10 inch? So let's see. So this is a circular ripple. Yeah, so you drop a stone, you see that in the water, in the lake, it creates the circular ripples which are expanding, right? So let R be the radius of this guy. So area is going to be, since it's circular, area is going to be pi R square, right? Now, you're given the radius is increasing at the rate of 2 inches per second, all right? So your R, radius is a function of t, right? Radius. Why is it a function of t? Because as the time keeps on increasing, the ripples basically expand, right? So that makes area also as a function of t, right? So take dA by dt is going to be d by dt of pi r square. Now think about r as r of t the square. Yeah. So this is going to be pi is a constant, comes out. What is derivative of r to the power t? R square, sorry, r of t square is going to be 2r of t multiplied by derivative of r of t, which is dr by dt. So what do we get? Therefore, a prime t equals to 2 pi r times r prime. Yeah, even though I'm not writing t for r, it's clear that r is a function of t. So I've written in both notations. So now the problem is asking what the radius is increasing at the rate of 2 inches per second. So I'm already given r prime equals to 2, or dr by dt equals to 2, whichever notation you want to use. And you're given r is what? 10 inches. So let's go and put this here. So what is happening to the area at that when r is 10? So you get 2 pi 10 multiplied by r prime, which is 2. So this is going to be what? 10, 20, 40 pi inch per second. So this is how the area is expanding, right? So we want to compute the derivative of this. So note that first we'll compute the derivative. So f of x prime is going to be what? F prime f of x times f of x prime, right? So derivative of outer function multiplied by derivative of inner function. So this is going to be f prime f of x multiplied by, now here again we have to use what? Chain rule. So this is going to be outer function is f. So f prime f of x multiplied by derivative of inner function, which is also f. So f prime of x, right? So therefore at x equals to 0, what do we get? The right hand side, sorry, the left hand side is f prime f of 0 times f prime f of 0 times f prime of 0. Now, what is f of 0? F of 0 is 0. So this will become 0. That means then again it's f of 0. So this is 0. So f prime of 0 is 1. So we get first part to be 1. Same way here, f of 0 is 0. So this will become f prime of 0, which is 1. And f prime of 0 is 1. So we get 3 times 1, which is 1. Okay, so let's move on to the next part now. All right. Let's read this problem. So under certain circumstances, a rumor spreads according to the equation P of t, which is equals to 1 over 1 plus a e to the power minus kt, where PET is a proportion of the population that knows the rumor and at time t, and a and k are positive constants. Okay, so that is important, that it's a positive constant. So now what is limit as t goes to infinity of P of t? So this is going to be limit as t goes to infinity of 1 upon 1 plus. Now to understand this better, I can write it as a upon e to the power kt. Right. Now as t goes to infinity, what can you say about e to the power kt? Where does that goes to? So if t goes to infinity, e to the power kt goes to infinity, as since k is what? Greater than 0. So 1 over that goes to 0. So you get the whole thing. So this goes to 0. So we get the answer to be 1. Right. Now the next question is find the rate of spread of rumor. So in that case, you want to find out P prime T. So first I will write P of T as 1 plus a e to the power minus kt to the power minus 1. So then P prime T, so that I can employ the chain rule, I get minus 1 times 1 plus a e to the power minus kt to the power minus 2 d by dt of 1 plus a e to the power minus kt. Now this is going to be minus 1 plus a e to the power minus kt to the power minus 2, and derivative of inside is derivative of 1 is 0, a is a constant which comes out, derivative of e to the power minus kt is e to the power minus kt multiplied by derivative of minus kt, which is minus k. So then the answer is k a e to the power minus kt over 1 plus a e to the power minus kt the whole square. So this is your derivative.